We are going to continue our lesson where our goal is that I can explain the properties of rational numbers. Just quick reminders about a few things. Rational numbers, we use that Q symbol, includes any number or any numbers that can be written as a ratio of two integers. The denominator cannot be 0, by the way. So if I was to write a number like this, would this be a rational number? No. 3 over 0 is not rational because we cannot have 0 in the denominator. If I wrote it like this, let's say we have 7 over pi. That's also not rational because the bottom is not an integer value, a non-zero integer value. Remember, rational numbers, any number that can be written as a ratio of two integers. So we could have it like -7 over 3. That's rational. Okay, that's just a quick reminder. We need to remember what rational means. Irrational numbers cannot be expressed as fractions or integers. This would be things like pi, like square root of 11, square root of negative square root of 13, so on. Any square root that's not a perfect square is irrational. Pi is irrational. The Euler number E is also irrational, and so on. There's an infinite amount of those. We could also have like 7 pi. That's also irrational. Okay? I know we talked about this yesterday. We're just going to go over it again really quick. A set is closed under an operation, for example, addition, subtraction, multiplication, and division, when you perform the operation on numbers in the set and the result is still in the set. We talked about this yesterday as well. I just want to give you guys another example of this. So we are going to do for an addition, subtraction, multiplication, and division. And let's say that we have this as our set. Let's say we have 7, 14, 21, 28, and this goes on forever. Okay? Let's say we have this. Let's make sure that this is closed under these operations. Addition. If we took 7 or any of these numbers, for example, let's choose 7 plus 28. 7 plus 28 equals to 35. 35 is the next number in the set because this is a number of multiples of 7. Only the positive numbers that are multiples of 7. So for addition, this would be closed. That one would work. For subtraction, if it's only positive, there's an example that shows that this would not be closed. For example, if we have, let's say, 7 minus by 14, that is equal to -7. -7 is not in this set, so this would be showing that this is not closed under this operation. Remember, it's only closed under the operation if it remains within the set. Okay, we had to land back into the set that we are working with. Multiplication, let's say that we did 7 times 14. Let's figure out what that is. 14 times 7. 7 times 4 is 28. 7 times 1 is 7, plus 2 is going to be 9. By the way, multiplication of this is going to be closed because these are multiples of 7, right? If you multiply 7 by anything, that's a multiple of 7. So it's going to be closed under multiplication. Division, this one is not closed. Division and subtraction are the hardest ones to make sure that they're actually closed. Okay, those are the hardest ones. For example, let's say that we had 7 over 14. That is equal to 1 over 2. That is not within the set. So that is why it's not closed under division. Okay, so that's just a few reminders of what we talked about yesterday to just reiterate the same message that we talked about. And hopefully it's starting to make a little bit more sense. Here are the properties of rational numbers. I wanted to make sure that we actually list them out. Okay, I want to make sure that we actually list out what the properties are so that you know what it means to be a property of rational numbers. Because in the last video, I did not do a well enough job of making sure that you guys knew what the properties actually were. Okay, so these are the properties of rational numbers. Rational number. If we were to add or subtract a rational number, it will always be rational. Okay? So this will always be a rational number. And I'm just going to use our symbol instead of having to spell it all out, just to try to save a little bit of time. So rational plus another rational is always going to be another rational number. Okay, I spoke this yesterday. I just wanted to actually write it down for you guys. A rational times another rational is going to be rational. Always. Okay? So if we take two rational numbers, add them or subtract, it's a rational. If we take a rational times a rational, that is also a rational number. Okay? And we're going to look at a few examples in just a little bit. By the way, by saying that it's always a rational, we are saying that it is closed under multiplication. We are saying that it is closed under addition and subtraction. A rational divided by a non-zero rational. Remember yesterday we had the example where we said, well, if it's zero, then it's not rational. We're going to make it so that it's automatically not a zero on the denominator. Okay? If this is true, it's still a rational, saying that it is closed under multiplication. Okay? That is the properties. These are the properties of rational numbers, but we like to put a mix in there to make it a little bit more interesting. Properties of rational numbers, it's just those rational numbers. Now we're going to add in the irrationals, just to have a comparison to see how they counteract, how they act together. Okay? A rational added to or subtracted to an irrational number, like I mentioned yesterday, I believe, is going to be not rational. Okay? No matter how hard you try, a rational and an irrational will always be not rational. It will always be an irrational number. A rational times an irrational number will always be an irrational number. Okay? And a rational divided by an irrational will always be an irrational number. Okay? So this is whenever we are comparing the two with these operations. Lastly, we want to make sure that we look at the, irrational with non-zero rational number is also an irrational. I need to make sure I put that one as well. Okay, so this is whenever we are comparing the two. Whether you put a rational or irrational in front or behind, it's always irrational and so on. Now we're going to compare just the irrational numbers because this is the one that is actually interesting. Okay, whenever you are comparing just the irrational numbers, these are the ones that are interesting because sometimes it is rational. Sometimes it's not rational. And I'm going to give you some examples of when it is or when it could be and when it might not be. So for example, irrational plus a irrational or minus an irrational. I'm going to give you an example of this. Let's say we have, let's go with a pi plus, let's say, a negative pi. That right there is equal to 0. And that is rational. That is rational, right? That is an example of when it would be a rational number. But it's not always a rational number. We could have, let's say we have square root of 3 plus square root of 7. That right there would still be irrational. This right here would not be a rational number. I'm not even sure what that would equal. We would have to end up approximating. We would have to turn those into decimals and then add the decimals, but even the decimals we don't have an exact value for because these go on forever. They never end, and if you take two things that never end, it's still going to never end. Okay? So this one right here, sometimes rational, but other times irrational. It just depends on what you have. So that's an interesting case. Whenever you have two irrational numbers added or subtracted, it depends. If you take two irrational numbers and multiply them, it's also going to depend. Okay, so for example, let's say we have, let's go with square root of, let's go with 2 times square root of 8. Okay, we have 2 square roots. Individually, those are irrational. Together, whenever you multiply them, square root of 2 times square root of 8, just to give you guys a little bit heads up about how we multiply square roots, we just multiply the numbers together. So this would be square root of 16. 16 is a perfect square. 16 is 4 times 4. So square root of 16 is 4. And that is rational. Let's see if we can find a case that would end up to be irrational, right? So here's a case whenever it is not rational. Let's say we have square root of 3 times pi. That right there, I don't know. We would have to figure out, we would have to round our decimals, then we could multiply them. We would not be able to actually figure out how it ends because it goes on forever and ever and it's not going to repeat. So this right here is an example of one that would not be rational. So 2 irrational numbers together with addition or subtraction, it depends on what you have. 2 irrational numbers multiplied, well, it depends. It depends on what the irrational numbers are. And 2 irrational numbers divided by each other, which this one on your homework I saw a lot of you guys mess up on. Let's take 2 irrational numbers and divide them. Let's say we have 3e divided by negative 7e. Okay? They both have e in common. So let's get rid of them. Divide top and bottom by e. So this can be equal to negative 3 over 7. That right there is rational. Okay? We could have an example of an irrational number. Let's say we have square root of 7 divided by square root of 10. That right there, we would not be able to necessarily do that because without having to round the decimals. We would have to round the decimals at some point because it goes on forever. Both of those would go on forever. They would divide and still go on forever. So this right here is an example of when it could be irrational. Okay? So notice, rational numbers, if you put them together, that works out nicely. It's always rational. Irrational and rational, if you mix them together, it's always going to be not rational. Then if you have 2 irrational numbers and try to mix them together, it depends. Okay, so that's the main point that I wanted to try to point out yesterday that I did not do as well of a job at doing, that I wanted to make sure that I explained again today. Another thing, I want to go through a few examples with you guys. This is going to really help you out on some of the homework questions as well. Let's remember what we just talked about. Okay? Those of you who wrote it down, excellent. So you can look back at your notes. Those of you who did not, you may want to take notes next time. So 9 plus square root of 45. Are they irrational? Are they rational independently? What are they? So what we have, 9 we know is a rational number. We know that's rational. We know we're adding. Square root of 45, is that rational or irrational? Well, 45 is not a perfect square. So this would be not rational. Going back to what we had up here, a rational and an irrational number added together is always irrational. So we know instantly that this is going to give us a not rational number. Okay, that's part A. Just knowing the facts makes it so that you can answer these questions more simply. This one, we have square root of 20. That's not perfect. We have square root of 5 on the bottom. That's not perfect either. But before we jump to conclusions, let's make sure that they actually don't have anything in common. Okay? So square root of 20 is really 4 times 5, right? So we still have this 2 square root of 5. 4 is perfect. Square root of 4 is 2, so that goes on the outside. So we end up with 2 square root of 5 divided by 2 square root of 5. It's the same on top and bottom. So let's divide both by that. So this would be equal to 1. Is 1 rational or irrational? It is a rational number. Okay, so this one right here, let's go back to our list. We said we had an irrational divided by an irrational. Going back to our list, didn't we find out that it just depended on the numbers? With the irrational divided by irrational? That's how we knew we had to check. Irrational numbers together, we had to check to see if it's actually going to be rational or not. If you have a mix, we don't have to check. If we have just rational, we don't have to check. This one, this right here is a rational times a not rational number. Looking at your list, do we have to check this one? Go back here, rational, irrational, always irrational. So we know instantly that this right here is not rational. For D, this is a irrational and an irrational. So we have to check it. If you go back to your list, double check. Okay, so square root of 7, nothing perfect. Square root of 9 is a perfect square, so this would be 3. Wait, so by simplifying, we actually find out that we have a irrational divided by a rational number. At first glance, we had just 2 irrationals, so we had to simplify it. We find out that it's actually a mix of the two. And the mix of the two is always irrational. Okay, remember your list. Go back to the list. Double check those. Make sure you know what the properties are. This right here, this is a rational times a not rational number, an irrational number. So we have to check. Right? Well, going back to our list, a rational and irrational, we said was always irrational. I want to check one thing with this. Square root of 25. What's square root of 25? Isn't that perfect? Square root of 25 is really just 5. So this is 3 times 5, which is 15. So in reality, we do have to check every single time. We need to make sure that if we can simplify, we simplify. So right here, this turned into a rational times a rational number. So be careful before we jump to conclusions. Make sure that we cannot simplify things down before we say it is or isn't. Okay? Double check for those perfect squares. If it's perfect, simplify it. If it's not perfect, leave it alone. This right here is a irrational times irrational. There's no simplifying that. Besides, if you want to multiply, you can say that this is 10 pi squared, which is still not going to really work out very nice. So if we simplify it, actually, 10 pi squared, this is going to be a rational times a not rational number. So this would be not rational. Okay? Last two. We're almost done. There's a lot going on with this one. We have parentheses. Let's go ahead and get rid of those parentheses. So we are going to move that negative in. We have 7 minus by square root of 3 minus by 3 plus square root of 3 minus by 4. Gather like terms, put stuff together. Negative square root of 3 and positive square root of 3 added together is 0. So we really have 7 minus by 3 minus by 4. 7 minus by 3 is 4. 4 minus by 4, 0. 0 is rational. Okay? Last one. We have an irrational number minus by an irrational number. Okay? Irrational minus irrational, we do need to check. So let's just subtract those fractions. So 4 over 5 minus by 3 over 1. Of course, there's pi in there. We like pi. So this would be equal to 4 pi over 5 minus by 15 pi over 5, which gives us a negative 11 pi over 5. That is going to still be irrational because we still have that pi mixed in there. So this is not rational. And that is the properties of our rational numbers.